Okay. So yeah, so let's see. Let's start with the next unit, that is machine learning models, right? So in the previous sessions, we talked about these two, fundamentals of data science and introduction to machine learning, and we talked about some, what you can say, the concept of machine learning, why machine learning, applications of machine learning, what is training testing. Then we talked about types of machine learning and supervised, unsupervised, semi-supervised, right? So all these concepts we are going to require to understand the remaining things, whatever is mentioned in the syllabus. Okay. Now, as we want to start with this third unit, machine learning model. So what I will do is, the first topic itself they have mentioned is linear models, right? Now to understand about these linear models, uh, I will try to discuss linear regression. So what happens is, as we want to discuss linear models, what I will be doing is, at the end of this particular topic, I will be showing you one model which will be created. Okay, and that model we are going to actually will go and we will deploy it onto cloud, right? So let's see how it all goes. What I will do is, I will try to explain the theoretical part of linear regression first, and then I will go and I will try to explain you what is a linear model. Okay, just a minute, there I think I lost the connection. Just a minute, guys, let me share the screen once again. Okay, I hope everyone is able to see the screen. So just a minute, I lost the connection. That's why. Let me see. Okay, so I was discussing about linear models, right? So first of all, we will start with the theoretical point. For that, let me. So as we want to discuss about linear models, so first of all, I will try to talk about very basic algorithm in machine learning. Okay, see those people who joined just now. I have started with this particular unit, third unit, machine learning models. So just to get an idea about machine learning models, just give me 2 minutes, guys. I'm not able to. I'm facing some problem here. Just a minute. So machine learning models. This is what our topic is. Now, to make some sense out of this, I will start with basic algorithm linear regression. So first of all, let's discuss the theoretical concept about linear regression. What is linear regression, and what is the idea behind linear regression, and why it is actually used? If you people remember, when we talked about different types of machine learning, right? So in types of machine learning, if you people remember, I talked about supervised learning, unsupervised learning, right? Semi-supervised learning, and yeah, supervised learning, unsupervised learning, semi-supervised learning. Okay. Now see, in case of supervised learning, I told you can solve the problems of prediction or regression, we call it, right? So regression problems or prediction problems, they actually come under supervised learning approach. And one more type of problem which comes under supervised learning approach is classification problems. And under unsupervised learning, the type of problems which come are clustering problems, right? Clustering is nothing but grouping. Now talking about supervised learning, just to talk about this prediction or regression, there are different algorithms. So linear regression is one of the basic algorithms which can be used to solve the problems of prediction or regression. Okay, so for example, maybe for example, someone comes to you, some client comes to you, and comes with a problem. Client comes to you with a problem that they want to create such a model which is going to predict the marks of a student, right? How many marks the student is going to score in his next exam based on his previous marks, maybe based on his scores in practice exam, how many marks is going to score in the final exam. Okay, so this kind of a model you want to create, you can actually solve that problem with the help of linear regression, right? So that's what we will try to do here. What we will do is, I will try to take a very simple problem statement, we will try to solve it theoretically. Okay, and then we will go and we will try to see the implementation. Let me tell you, the basic idea behind linear regression is that here what we do is we try to make use of a equation of straight line. I hope you people are aware about the equation of straight line. See, we have actually studied about equation of straight line in school, right? So y is equal to mx plus c is the equation of straight line, where this m is the slope and this c is the y-intercept, I guess. We will see. If you people are not aware about what is slope and what is intercept, or if you do not remember it, no problem. We will try to make some sense out of this with the help of some example. Now see, this is the equation of straight line. Now the question is, how linear regression makes use of equation of a straight line to solve such types of problems. That's what we want to understand actually. Okay, many people write it down. Many people write down this particular equation like this: y is equal to beta 0 plus beta 1x. Right? Again, where beta 1 is the slope, where beta 1 is the slope, and beta 0 is the y-intercept. Okay, so you can actually write down it like this, or many people write it down like this: y is equal to b0 plus b1x. Again, the same. Okay, so we will try to make use of this particular variables. Y is equal to b0 plus b1x, where b1 is the slope and b0 is the y-intercept. Okay, so as I told you that this linear regression is going to make use of the equation of a straight line. What actually happens here is, see, suppose now see you have a data. Now maybe these are the marks. Okay, these are the marks scored by a student in practice exams. Okay, and these are the marks which you want to predict. Suppose this is the x and this is the y. Now you have a lot of data points. Okay, so maybe for example, lot of data points like this. Your data, it looks like this. Okay, lot of data is there. Okay. Now, as I told you that it is going to make use of the equation of straight line. So what ultimately is going to happen in case of linear regression is, we are going to draw a straight line which is going to pass through dense area. This line is going to pass through dense area from this from all these particular points. So what do you mean by dense area? It means that it is going to pass through such a area, such a portion of this particular uh, all these data points in such a way that there are a lot of data points around this particular line. How to, that means this distance should be as minimum as possible for each and every point. This line will be drawn in such a way that this particular line will be drawn in such a way that this distance from all the points will be as minimum as possible. How? That we will see theoretically first, and then we will implement it. Okay. So see, this is the basic idea behind linear regression algorithm, which with the help of which we are going to create linear models. Right. So even if you have not understood this, but yeah, this is the overall idea. What I will do is, now I will try to take a simple example, and then for that example actually we will try to predict something, and for that we will draw this kind of a line, and we will use this kind of equation. Okay, y is equal to mx plus c, or equation of straight line. So let me start with a simple example first, and let me tell you what we are going to actually predict here. As I told you, linear regression is actually used for what? Linear regression is used for prediction or regression, for solving the problems of prediction or regression. Right? Now you might have come across those people who read, they might have come across many problems which can be solved with the help of linear regression. So for example, we have some data set. In that data set, suppose uh, the given data set is something like, yeah, suppose I will take an example from the syllabus of some university, which is generally referred. Actually it will be easy for you to understand. Suppose I have a data. Now we have the ratings given by people to a certain movie. So person 1 has given some rating to some movie. So maybe person 1 has given some rating to Bahubali part 1. Okay, so to Bahubali part 1, okay, person 1 has given some rating. Similarly, person 1 has given the rating to Bahubali part 2 also. Okay, so this is the example which we will find out in many of the university syllabus, or general example, very simple example. So actually I should write a person 1 here. Okay, so different people have given different ratings for Bahubali part 1 and Bahubali part 2. So person 2 has also given some rating, person 3 has also given some rating, and like this. See, in real time what should happen is, actually we should have a lot of data, but I cannot show you a lot of data here actually. But to understand the concept, we will take a very small example, very small data set we will consider here. But yeah, let me tell you, in real life or in real time, obviously it will not be possible to just create a model or just to train the model with the help of this much of data only. Okay, so suppose there are 6 people who have given some rating to Bahubali Part 1 and Bahubali Part 2. Suppose Bahubali Part 1 we will name it as column X, and this we will name it as column Y. So person 1 has given out of 5 person 1 has given 4 rating for Bahubali Part 1 and 3 rating for Bahubali Part 2. Similarly, person 2 has given 2 and 4. Okay, suppose 3 and 2. This is just an example. Suppose 5 and 5 it is given. Suppose fifth person has given rating 1 to Bahubali Part 1 and rating 3 to Bahubali Part 2. And maybe this person has given like this, 3 and 1. Okay. Now, what we want to do is try to understand the problem statement. What we want to implement. Okay, so this is the data given to us from the client. Just assume that. Now, we want to create such a model which is going to help us to predict what will be the rating of Bahubali Part 2. Given that if 7th person comes and he gives the rating as 3.5 to Bahubali Part 1, so our model should be able to answer this particular thing. I hope everyone is able to understand the problem statement. If there is any doubt to anyone, I am ready to repeat it. Very simple problem statement, right? I hope no one is having any doubt. Everyone clear? What is the problem statement? Okay. If there is any doubt, yeah. So people are saying yes. So I hope everyone is clear about what we want to actually get with the help of this model, right? Now let me continue. So if person 7 gives 3.5 as the rating for Bahubali Part 1, what will be his rating for Bahubali Part 2? Now, as I told you that we are going to make use of equation of a straight line. So equation of straight line is what I told you. Y is equal to b0 plus b1x is the equation of straight line, where b1 is the slope and b0 is the y-intercept. Now, if we want to get the value of y and x, let me see, y and x, right? Y and x. That means we need to solve, or we need to get the value of b1 and b0. Now, the equation to solve for the value of b1 is something like this. b1 is equal to summation of, this is a summation sign actually, let me write that properly. So b1 is equal to summation of x minus x bar. What is this x bar? I will tell you, don't worry. And y minus y bar. Again, what is y bar? I will tell you that. So b1 is equal to summation of x minus x bar into y minus y bar divided by summation of x minus x bar whole square. So this is the formula to solve for b1. Now what am I going to do is, According to this particular formula, to solve for B1, I am going to calculate the value of x minus x bar, y minus y bar, and x minus x bar whole square, and x minus x bar into y minus y bar. See, what I am going to do is, now what is x? Vowel part 1. What is y? Vowel part 2. So I am going to solve x minus x bar. I am going to find out the value of x minus x bar. Similarly, I am going to find out the value of y minus y bar. Obviously, for that one needs to find out what is x bar and what is y bar. That we will try to find out. Okay. So after that, what do we want to need according to the formula? We need x minus x bar whole square also. And okay, finally, what we need is x minus x bar into y minus y bar. These are the things which we are going to need to solve for the value of b1. This is what we want. Now, okay. So x bar the mean subtracted value. X bar is the mean actually. Who is asking that? Sharon. X bar is the mean. I will tell you that. Yeah. See, how to find out x bar and y bar? So I will write out the value of x bar and y bar. So x bar is simply the mean, that is average. Now tell me, what is the mean of x? What is the mean of x? That is this value. So 4 plus 2, 6. 6 plus 3, 9. 14. 15. 15 plus 3, 18. So 18 divided by 6. So x bar value is going to be 3. Similarly, if you go for y bar, 7 plus 2, 9. 9 plus 5, 14. 17, 18. It is also 3. Right? So, sorry, it should be 6. So it is 3. So x bar is 3 and y bar is 3. Now you can easily find out the value of x bar and y bar. X minus x bar and y minus y bar. So what is x minus x bar? Value of x is 4. Value of x bar is what? 3. So 4 minus 3 is 1. Similarly, 4 minus this 2 is 2. 4 minus 3 is 1. 4 minus 5 is minus 1. Sorry, not 4 minus 5 actually. What is that? 5 minus, you see, it should be, let me correct it. 2 minus 3 is minus 1. Again, this is wrong. See, 4 minus 3 is 1. 2 minus 3 is minus 1. It should be minus 1, right? 3 minus this 3 is, it should be 0. Try to understand, x bar is 0. I am trying to find out x minus x bar. This is my x. Okay. 5 minus 3 is 2. Then 1 minus 3 is minus 2. And 3 minus 2 is 1. This is what x minus x bar is. Now, what is y minus y bar? Say, y bar value is again 3. Like here you can see. So, what is 3 minus 3? So, 3 minus 3 is going to be 0. 4 minus 3 is 1. 2 minus 3 is minus 1. 5 minus 3 is 2. 3 minus 3 is 0. 1 minus 3 is minus 2. Right? So, this is what x minus x bar is and y minus y bar. Now, I want to find out x minus x bar whole square. So x minus x bar is this. So what is x minus x bar? So 1 square is 1. What is minus 1 square? 1. 0 square is 0. 2 square is 4. Minus 2 square is 4. And 1 square is 1. I hope everyone is able to understand whatever I am trying to do here. I am doing a simple calculation, right? Very simple. So x minus x bar. Now what we want is summation of x minus x bar. I hope you people understand what is the summation. Addition, right? So just go. 1 plus 1, 2. 2 plus 4, 8. 8 2 plus 4 6, not 8. 2 plus 4 6. So see, 1 plus 1 2, 2 plus 4 6, 6 plus 4 10. Did I is there any mistake actually? Let me check once again. I think it should be 10. Summation of x minus x bar, x minus 4, sorry. See, here we had a mistake actually. Let me correct. See, what value you want to find out here is x minus x bar whole square. So it is 1. This is 1. This is 0. Then 4. This was right. This was right. Okay. So actually here it should be 0. See, this should be 0 actually. Because this 3 minus this 3, it should be 0. And that's why I will get 0 here. So 4 plus 4, 8. 8 plus 2, 10. So x minus, summation of x minus x bar whole square is 10 actually. Okay? That's what the value. Now, what is x minus x bar into y minus y bar? That is multiplication of these two columns. So 1 into 0 is 0. Minus 1 into 1 is minus 1. My 0 into minus 1 is 0. 2 into 2 is 4. Minus 2 into 0 is 0. 0 into minus 2 is 0. Now if you go and if you try to find out the summation of this, Why am I trying to find out the summation? Because of this formula. Summation of x minus x bar into y minus y bar. What is that? 4 minus 3. Sorry, 4 minus 1 is 3. So we got this. Now, according to this particular formula, if we put all the values which we calculated here, we can easily calculate the value of b1. So this formula gives us what? Summation of x minus x bar into y minus y bar. What is that? It is 3. So in the numerator we got 3. Divided by what is summation of x minus x bar whole square? This is 10. I am going to get 10 here. So what will be this? This is going to be 0.3. Right? So value of b1 we got is 0.3. Right? Now what's next? Now we are not yet done. After the value of b1, we also need to find out the value of b0 because b0 plus b1 x is actually. So to find out the value of b1, what we are going to do is actually we are going to consider mean values now. So see, what is our equation? Our equation is y is equal to b0 plus b1x. Now, instead of this y and x, what I am going to do is, instead of this y and x, I am going to consider the mean values or the average values. So it is going to be y bar is equal to b0 plus b1x. So what is the value of y bar? 3. What is the value of b0? We want to find out. What is the value of b1? We just now found out. 0.3. What is the value of x? Again 3. So if you go and if you try to solve this, so it will be what? 3 is equal to b0 plus what is this? 0.9, right? So it is going to be 0.9, and which gives us the value of b0 as, so it will be what? 3 minus 0.9 is what? 2.1. So the value of b0 now is 2.1, right? So we got the value of b1 and we got the value of b0. Now we can go and we can make use of this particular equation, that is y is equal to b0 plus b1x, and we can get a straight line. Now my equation is going to become what? Y is equal to, what is the value of b0? 2.1. What is the value of b1? 0.3. So 2.1 plus 0.3x. This is what our equation of straight line is. Now, yes, definitely we got this particular equation here, but how to represent this particular thing graphically? So just to make sense out of this and to answer this particular question, I am trying to draw a graph here, something like this. See, this is what our y-axis is. This is what our x-axis is. Now 0. Suppose this is 1. This is 2. This is 3, and this is 4. This is 5. Right. So this is what actually x, or we can say rating given by the people for Bahubali Part 1. And this is what this y-axis is representing rating given by the people to Bahubali Part 2, Bahubali Part 1 and Bahubali Part 2, x and y respectively. Similarly, here what I will do is 0, then 1, then 2, then 3, then 4, and then 5. Okay. So we have x and y axis here. Now, what is the first point? First point is 4, 3. Now, how we gonna represent 4, 3? So you can check 4 is here and 3 is here. So 4, 3 point is going to come somewhere here. Okay, this is going to be 4, 3. What is the next point? Next point is 2 and 4. So where is 2? 2 is here. Where is 4? 4 is actually on y-axis. I need to check. Right? So 4 is here. So 2, 4 is going to come somewhere here. So I am simply trying to plot the points which are here. So similarly 3, 2. Where is 3, 2? 3 is here and 2 is somewhere here. Sorry. Let me see. 3, 2 is going to come somewhere here. Then 5, 5. X-axis 5 and y-axis 5. So 5, 5 may be somewhere here. Okay. And then 1, 3. So 1 and 3 is going to come somewhere here. And then 3, 1. So 3, 1 suppose here. So how many points are these? 1, 2, 3, 4, 5, 6. Because we have 1, 2, 3, 4, 5, 6. We have ratings given by 6 people. What we want to do is we want to predict if this 7% gives 3.5 rating for Bahubali Part 1. What will be his rating for Bahubali Part 2? This is what we want to actually predict. Right. So for that, what I told you initially, linear regression is going to make use of equation of straight line. So first of all, we need to draw a straight line. Now to draw a straight line, we need at least 2 points. So that's what I am going to do. The first point is going to be the mean. What is the mean actually? Mean is average point. So what is our mean? 3, 3, right? Mean is going to be 3, 3. So see, because we already shown you, I already showed you, right? 3, 3. So this 3 is here and this 3 is here. Suppose mean is going to come somewhere here. So this particular point is nothing but mean. So first point we got. What is the next point? The next point is slope value b1. What is sorry, not b1, b0, y-intercept, not slope value. Y slope value we actually used to find out the y-intercept. What is our y-intercept in the equation of straight line? B0. What is the value of B0 we found? 2.1. So the next point, y-intercept is nothing but what? The point at which it cuts to or intersects to y-axis. So 2.1 is somewhere here, suppose, right? Somewhere here. So this is 2.1. So that means we got this point and we got this point. Now we can easily draw a straight line passing through these 2 points. So that straight line is somewhere, suppose, like this. That straight line is something like this. Okay. Obviously, it's not accurate, but yeah, this is a straight line. Now our model is ready. Now you can go and you can ask any question to the model. So what we wanted to find out? We want to find out now that if some person comes and if it gives the rating as 3.5 for Bahubali Part 1, what will be his rating for Bahubali Part 2? This is what we want to predict actually, right? With the help of this model. So if some person comes and he gives the rating as 3.5 here, so what we can do is from this particular line, draw a perpendicular line here and just draw a perpendicular line here. So we will get the corresponding value of y. Right? Suppose this is 3 point maybe 4. So our answer is going to be 3.4. Okay, see, obviously it is not accurate here. This is just for your understanding purpose, right? So see, whatever the line which you got here, this line is actually called as, remember this is very, very important, line of best fit. Okay, this line is called as line of best fit, or we call it as best fit line. Best fit line. Now, what is the best fit line? Best fit line is the line which always passes through dense area. Now, how we have actually drawn a this particular line which is going to pass through dense area? So, see what happens is, even when we will implement it, at that time also you can go and you can plot this line of best fit with the help of some packages like you can go and you can make use of matplot, you can see one package. Right. So at that time, if you go and if you try to plot, you will notice that we draw or actually linear regression helps us to draw this particular line in such a way that this particular distance should be as minimum as possible. This particular distance should be as minimum as possible. See, all these orange color markers are the actual values, and the corresponding values on this line for those points are actually the predicted values. And the difference between them, that is this is called as residual. Try to understand. This is called as residual or residual of, see, this error is very, very minimum. This is very, very less. Residual, or it is also called as error. Remember this, okay? Residual or error. So our target will be what? Our target will be to minimize this error. This distance should be as minimum as possible. And line of best fit will be drawn in such a way that this distance should be as minimum as possible. So if it is not, just to improve the accuracy of the model, what we will be doing is we will try to go and try to minimize this particular distance. That means indirectly we will try to minimize the error. Remember, whenever I say residual or error is one and the same thing. Okay, these points are very, very important. So this is a very simple example of how theoretically one can make use of linear regression for prediction or regression. Right? I already told you, either you can say prediction or regression, one and the same thing. Okay? So there are some points one needs to keep in mind. Right? What is line of best fit? So this line is called as line of best fit. Whatever we had drawn just now. Okay? This complete. Again, see, we know that the nature of straight line is not going to change. Straight line is always going to be straight. So if someone comes and if someone asks me what will be the rating for Bahubali Part 2, if some person gives a rating as 4.5 for Bahubali Part 1, so yes, you can go and you can Follow the same procedure. From this line, draw perpendicular line. From this line, draw corresponding perpendicular line. And this line, this particular point is going to give your answer. Right? So in this case, now try to understand this particular thing. This is what our input is. Okay? And this particular thing, this particular is our output. This column is our output. Or there are other names also. You will see people making use of different names for input and output. So we call it as input column and this will be your output. Obviously, in real time, what is going to happen? In real time, your input is not going to be only one column or only one feature. Input is going to be more than one features. Okay, we call it as feature, we call it as column, we call it as attribute, we call it as independent variable. Okay, so one and the same thing, and this one is called as target or label, all the or the output, and generally we represent it as y, and input we represent with x. I will again repeat. In this case, for this example, only one feature is actually assigned to x, but in real time, what's going to happen? In real time, there will not be only one feature or only one column, there will be more than one column. So try to understand that. Okay. So see, this is what we have used. I will just try to go through this particular thing once again. This is the equation of a straight line which we have used. After that, from this particular data set and according to this particular formula, we try to find out the value of b1, which is a slope. With the help of b1, we found out the value of y-intercept p0. Okay, with the help of this x bar and x bar and y bar are actually the mean or the average. Once we got the value of b0 and b1, we draw on this particular line, which is called as line of base fit. And from the line of base fit, we got our answer. Or from the line of base fit, we actually were able to predict for the required question or whatever they are asked. So this is a simple example just to talk about concept of linear regression actually. When I will go and when I will show you the implementation of linear regression, definitely I'll be talking about the maths which is involved behind this particular thing. Okay, and then I'll be showing you a proper implementation of linear regression model. And in that case, maybe you will come across where I will be showing you how we practically go and practically divide the data into training and testing. If you people remember in the second unit which we talked about, in that unit we have seen how to we have seen training and testing and training, right? So how actually it is done, that we will see practically before implementing this particular linear regression. Because what happens is before creating any model, as our third unit, the unit which we started with today, as our third unit itself is machine learning models. So before talking about any model, before creating any model, one needs to be ready with the data. Whenever I say ready with the data, it means what? It means you should be ready with the processed data. Your data should be clean data. So whenever I say processed data, whenever I say clean data, what do you mean by that actually? That's what I will be showing you practically. Okay, before implementing with the model. So, but for that, well, yeah, obviously, one needs to understand the concept. One needs to be aware about the concept of linear regression. If you are aware about concept of linear regression, definitely all these things are going to help you to understand the algorithm better. And once you understand linear regression, you will be able to make some sense about the remaining algorithms also. Let me tell you, see, linear regression is a very basic algorithm. Later on, I will when I will be talking about some different algorithms. Uh, at that time, I will tell you that okay, which one is the better. So because see, if you want to compare different algorithms, if you want to be really good in making a decision that which algorithm should be used for solving a particular type of problem, for that one should be aware about the logic behind that particular algorithm or the concept. Concept should be clear. I am not saying that you need to mug up it something here. Even if you are not aware of the formula, no problem. That's also okay. But you should be aware about the concept actually, how all these values are actually found out. So remember, whatever the terms I talked about here, those terms I am going to use repeatedly again and again. So I talked about residual. I told you residual is going to be the error. I talked about equation of a straight line. What is slope? I shown you how to calculate it. Y-intercept, how to calculate it. What is, yeah, residual error? I told you. What is input column? What is output column? Input column or feature or attributes or independent column we call it as. Output column or output or label or target we call it as, right? And generally input is denoted as x and output is denoted as y. These are just the variables. And this is a simple data given by client to us. I hope everyone is clear till this point. Anyone in doubt till this point? Do you have any question? Some people were raising hand in between. So do you have any doubt? Specifically, I am asking because some of them they were raising their hands. So I thought you people have a doubt. Yes, anyone any doubt here? Just let me know if you do not have any doubt. Just let me know about that. Yes, guys, any doubt? Those who are there. Okay. So I got one reply. So I think no doubt. People are saying that there is no doubt. So I think I am good to go. Okay. So see, this is a basic. These are the basic things about linear regression. Now, after this one, suppose you created the model. Okay. So you got the model for which you got this particular graph. For you got this particular line of this way. After this, actually, what happens? So suppose by chance. Uh, Again, how to find out the accuracy, how to check your model is good or not or bad or what, whatever. How to find out that we will see in implementation. So what we do after this is we try to find out something called as accuracy. How much your model has actually learned, how actually your model has performed. Okay, yeah. Before that, Saloni is asking one question. Can you explain how will these steps change when multiple inputs are there? So Saloni, in this case, you are, as you rightly said, how all these things are going to change if there are multiple inputs. So let me tell you, in this case, we have only one input. Even if we will be having multiple input columns, same steps are going to be there. Are you going to, is it clear, Saloni? Your question is right. But same steps are going to be there, even if there are multiple inputs. You do not have to do anything. Is it clear, Saloni? Same concept. So, what I'll be doing, that's why I told you initially. When I'll be going and when I'll be implementing linear regression. See, we actually here for this particular first topic, what I'll be doing is I'll be showing you a simple mini project where we are going to do prediction. We are going to predict something, and for that we are going to make use of some 500, 600 records rows, and near about 8 to 10 columns. I think 10 columns we are going to make 10 features. So that example is going to give a very clear idea how the steps are going to change. But I told you these steps are not going to change. This same concept we are going to apply even if there are multiple columns. But what is going to change is the only thing is that the number of steps which you need to apply for pre-processing the data, for cleaning the data, those steps will increase. That's it. Otherwise, nothing. But in real time, I told you, in real time, it is never going to happen that you are going to get only one column as an input feature. No, never. There are going to be different features. Okay, so that's why practically in practical implementation, I will show you more than one feature. Okay, so that was a good question, Saloni. So yeah, I think yeah, if suppose someone is having any doubt, you people also can ask. So that's what I am expecting. If you ask questions, then only it will be more clear, and I will also get the idea that whether you people are getting or not. So don't worry that okay your question will be wrong or something like that. Don't worry about all those things. Just go on asking your question, even if it's a foolish question, no problem. You should ask questions. Okay, so I hope everyone is clear. Now I was talking about what after this. Once you created this particular model, now what to do after this particular thing? So after this, there's a need to find out the accuracy. So for example, you created the model and your model is giving you 70% of the accuracy, but 70% of the accuracy, suppose if you are thinking that okay this accuracy is not good in my case, you want to increase the accuracy and you want to make it as maybe 90% or 95%. Okay, you want to increase the accuracy. Now whenever I say you want to increase the accuracy, it means what? It means you want to decrease the error, right? So let me clear everything first. Let me clear. See, whenever I say you want to increase the accuracy, it means what? Increase the accuracy means it means decrease the residual. Residual is nothing but I told you it's a error. Okay, So mathematically, what we do is, or mathematically, what happens at the back end, what happens is actually we try to find out, or we try to make use of derivative. Can anyone tell me what is the practical application of derivative? I hope everyone is aware about derivative and integration. Can anyone tell me why we actually learned about derivatives in maybe 10 plus 2 or maybe in your engineering in colleges? Can anyone tell me what is the practical application of derivative? Because generally what happens is once we go and once we actually complete engineering or graduation, then after that we actually get the idea why we learn this. So anyone, can you people tell me what is the practical application of derivative? Why to find out, or why we learn like derivative actually? Forget about this particular algorithm itself. That we will definitely discuss. Why? Why we have actually learned before? Why derivative topic was there in mathematics or M3 or M2, whatever. Used to cumulative records. So no, actually, Sharon, not actually, not for cumulative records. I hope you people got my question right. Anyone who is not able to understand my question, just you can ask me. I will reply it. My question is simple. Why we have learned about derivatives? What is the practical application of derivative? Slope calculation. I mean, it's saying okay, but yeah, but that's not the answer. Correct answer actually. I mean, to find rate in change of quantity. That is somewhat right side. But let me tell you to be more precise. Always remember why we learned about derivatives is derivatives are actually used to find out the minimum. If you want, if you people remember definition of derivative, right? Summation, right? Some I tends to zero, something like that. If you will remember, so the definition of derivative, go to the basic, yeah, to minimize Mosifada. So we always to minimize something or to find out the minimum value or to find out the minimum of something, we make use of derivative. So to increase the residual, to decrease the residual or to decrease the error, we gonna make use of derivative. In the background, this is what is going to be. How that we will see in implementation. Even I will be showing you what formula we use. Okay, but yes, just to clear about the concept, this is the practical application of derivative. Similarly, there is a practical use of integration on it. So that maybe we will discuss that later. Okay. So obviously, see if you go and if you decrease the residual of the error, obviously your accuracy is going to increase. So that's where we are going to make the derivative. Now, first of all, theoretically, what we're gonna do is we actually find out something called as standard error. We find out standard error. Now the formula for standard error is something like this: y minus y bar, sorry, y minus y cap. I will write it down. Okay, y minus y cap summation of this is the square of this. So summation y minus y cap whole square divided by n minus 2. Where this n is number of records, that is number of rows, that is number of observations. Okay. For example, earlier I said that okay, I am going to make use of 500 number of records to create a model. In practical implementation, we will see that maybe in next session. So this is the formula of standard error. Now what is this y? What is this y bar? So y is the actual value. Y is the actual value. And y cap is the predicted value. Predicted value. That means what? That means y minus y cap is going to be what? It is going to be the error or the residual. So this is the formula to find out the standard error. Okay. So whatever the example which we have seen, from that example I can go and I can find out the value of y minus y cap whole square. And n was this was what? In our case it was 6. 6 minus 2 is 4. So it is going to be 4. And in case of very large n, even you can actually ignore this 2. Okay, this 2 is very negligible actually. So this is how we found out the standard error. So for previous example, I could have actually shown you the standard error. Same data we could have actually made use of, right? So whatever I have shown you till now, remember those things. Residual is nothing but the error. What is independent column? What is dependent column? Or we call it as feature, right? Target or label is nothing but the output column. Predicted value, actual value. Difference between the predicted value and the actual value is going to be the residual or the error. And our target is going to be to minimize that particular error or the residual. That is this one. How? That's what we'll be talking about maybe in the next few sessions or maybe in the implementation. Because for that I'll be giving you some notes where I'll be explaining each and everything in detail. Okay, those who are interested for maths, learning math behind, definitely you will also get all the things which are required for that. Right? I hope till this point everyone is clear. So let me once again go to this. So see, we started with this. Those people who joined just now, for them we started with this particular unit, machine learning models. From that we started with linear models, and as we want to develop a model, that's why I started with linear regression. Okay, so let's see how it all goes. Maybe in the next session I'll be showing you some mathematics behind that. We'll be talking about all those things. So that's what I want to discuss today. Maybe the remaining things we will discuss in the last session, in the next session. Okay, and we'll try to revise the same things which we have discussed in the last session also, because we are going to require. So yes, guys, you can send your numbers and I will stop.